Okay, can I have a show of hands who knows Haskell or has heard of it? Ah, wow, excellent, cool. Okay, so Fay is a general purpose programming language, but it compiles to JavaScript, so it's basically web or node stuff. And I really like functional programming, and I love JavaScript, and I love that you can target the browser, you can target all these users all over the world, but the language itself, I'm not so happy with, so rather than sort of wait around and wait for someone else to fix the problem for me, I thought, well, I made a diagram, so if the giraffe is JavaScript, then the zebra is me with the stripes, and I'm kind of riding it to get to the decent leaves at the top to reach all the users, so that's the metaphor. So just a question, it's not really to make a point about static typing, it's just to get you thinking, maybe. How many exceptions do you have in your real code every day in production and development that bit you in the ass, that was basically an exception because either a type error or something wasn't in scope, an object wasn't there when you thought it would be there as a property, and stuff like that? How often does that actually happen in your code? So that's just a quick question, and I'll come back to it at the end. So, huh? Never happens. That's true. Yeah, it never happens. Okay. So it's a subset of Haskell, and so it's a proper subset, which means that every Fay program will compile with Haskell as well. So it uses the Haskell compiler as well as its own generator to JavaScript. So as a Haskell programmer, you already know Fay, basically, if you know Haskell. So what is the sort of aims of the project as a compiler to JavaScript? It's supposed to be non-intrusive, which means because it's a different language, like completely different to JavaScript, not like CoffeeScript, which is basically a kind of translator that adds some nice syntax, right? This is a different language completely. And so it's supposed to be non-intrusive, so it doesn't modify global stuff, it doesn't mess around with existing code bases, it remains inside of a nice little closure. And so you can use it in your legacy or your existing systems to play around with it or try to replace systems with it. It should be fast enough, it's the kind of language where speed is a problem if you're not an amazing compiler writer, so it's got to be fast enough, not amazingly fast, just enough so that you can write applications with it, you can even write 3D stuff, right? It just needs to be fast enough, and V8 and IronMonkey and these kind of things are amazingly fast now, so it should compress very well. So when you write a Fay code, maybe 5 lines turns into 10 lines of JavaScript, and that's normal. The same with CoffeeScript, right? You get this huge output. So what you want is that it becomes, say, it should generate code that targets things like Uglify.js and Clojure and stuff like this, so it outputs really small code. So it does that well. Interoperating with JavaScript means that you can use all the existing ecosystem of JavaScript, and that it should be really easy. You don't have to mess around with the runtime. It should just let you write what you want to write and then start going. And finally, the point which it doesn't really appear in CoffeeScript but does in Fay is to have the same language on the server and the client. So you see this in Comet and things like this, and maybe Oppa, if you've seen that, or which is a bit more obscure. And I'll talk about that in a little bit. So those are the aims. And overall, it's simplicity. So this is a diagram of a guy who's clearly happy and simple, thinking of Fay. So it's statically typed. So raise of hand, who likes static typing? Oh, that's not bad, actually. More than yeah. Okay, so the metaphor that I give is if your code base is sort of a jigsaw puzzle, then static types give you a kind of color coding, which lets you sort of figure it out more easily. I'm not here to sort of advocate static typing and all this kind of stuff, which either you've looked into it and it sort of speaks to you as a developer and your experiences, or it doesn't. So I'm going to represent what I like, and you can take from it what you will. So this is a weird feature. It's lazy, which means that every expression in the language is not evaluated until it needs to be evaluated, which is kind of like everything is deferred almost. So if you're a node developer and you're used to writing closures to sort of defer computations, then it might be somehow familiar, but imagine every single expression is like that. And that's what it's like. Yeah. It's pure, so you've probably seen this before. Everything is a pure value. So it's kind of like mathematical constants or a mathematical function. So it's a kind of mapping, right? So a variable never changes in the function body. It varies according to the call of the function, but that's about it, right? So you get this kind of equational reasoning, and the way you write code is completely different. Everything is immutable, and it's nice. So those are the kind of 3 main points. But as I said before, there's this guy from the 13th century called Mullah Nasreddin. Maybe if you're from the Middle East, you've heard of him, maybe not. But he's kind of like a Middle Ages kind of troll, like an epic troll of proportions. So he kind of went to deliver a sermon to a bunch of guys, kind of like this, but it was a kind of religious Sufism kind of thing. But he thought that either the people coming either had done the work and had the kind of insights that he had, or they hadn't, or had different insights. So whatever he said, it wouldn't really change their mind about it, right? All he can say is, go and do it yourself, have a look if you like it. If not, don't, right? So it's kind of like drinking the Kool-Aid. You either did or you didn't. So I'm not here to try to get you to use static typing, but maybe if you want to write your own language, for example, or something like this, then maybe this is a way to say, you can do it. It's okay, it works, and it's really easy. So that's the introduction. Now I'm going to go straight to demos, so that's more interesting. Yeah, is the internet working now? It's working. Cool, yeah, always. So if you go to, if you're on your laptop, you can go to IDE. Now, I'll make this bigger so you can see it. One sec. Yeah. Go to this address. Yeah, you can see it here. ide.faylang.org, and you can mess around with the code. So these demos. And I can see someone's already made a module. Right. So what I've done is implemented just for this talk a kind of IDE where all my demos are on the left. So I'm not really sure how to introduce it, but I can just show you that it works. So these are the things you can do. So I have my editor here, and it has the normal kind of, as you type it, checks the types and does stuff like that. That's nice. But then you load it in, and then you get the output below when the internet can respond fast enough. Okay, maybe I do it locally. Okay. So you load it in, and you get the output. So this alert is just one that I did for the demo, so I don't have to deal with pop-ups. So the expressions look like this. This is just normal Haskell, but the FFI, the foreign function interface, is here. So you say basically, this is the JavaScript that I want to be run when I call the function alert. And you state the type of the function, and this is the static type, right? So this is Fay's way of talking about functions. But you easily bind to JavaScript like this. So there are a bunch of demos, like a calculator. You can check these out yourself, right? There's a canvas demo. So it's somehow fast enough to do this kind of stuff. And again, you can check the code for that. But yeah, it just looks like normal Haskell. This compiles in Haskell fine. Someone actually made a binding to 3.js, which is pretty nice. It's really easy to do 3D stuff, and that's pretty sweet. Now, is the web still working? Is anyone on the site right now? On the IDE? Anybody on it? Can you try to create a new module by going here, new, and then typing in your name like this, demo or something, and then click create. Can anybody try that? And it should come up and we can see it. Your mom, nice, okay. Yeah, so if you copy some code from one of the other modules, you can paste that in and start messing around with it. And at the end, I'll show what anyone came up with, if they came up with something good, right? Okay. What are the other demos? Yeah. Top 10 is hiring. Right, exactly. You took advantage of the situation. Very good. I like it. Perfect. Okay, so before I mentioned server-side, client-side consistency. So that's kind of the main advantage you get with Fay, that you get an OPA and things like this. So here is a call to the server. Let me make this bigger. I guess you can't read it, right? So let's change the layout a bit, like this. So I call this function project modules, and it returns a list of modules. Now that's normal Ajax. There's nothing weird about it. But the fact is that it's statically typed. So in this module below, I have a list of commands. So, check the module, get the module, libraries. This is the code for the IDE itself. Create the modules, project modules, internal, stuff like that. And I specify what it returns and all this kind of stuff. So in the actual code, if I go to the editor, I have this server, which handles all the Ajax commands, right? So it does various things like loading modules, compiling. And then on the client side, I use it in various places. And what's really sweet about this is that if I change anything, like this actually doesn't make sense, so I'll delete that. Then I compile it. And then it tells me, like normal static typing things do, that this needs to be updated. So this is client-side code, which is statically typed now. And it's hooked up and consistent with what's on the server. So I change this, compile this, and then it says that the server needs to be updated, right? It says, this has too many commands. So I go up and delete it. And then I build, and then it's done. And your code is consistent again. There's no big deal. And yeah, I think that's a huge deal, because when you have like hundreds of these commands in a normal code base of an actual proper application, not just like 5 like this, and you don't have like one argument, you have say 10, you have a big object of stuff inside that you need to pass and take, right? That's a huge deal. For when you're in the tens of thousands of lines of code, it's a big deal to change this kind of stuff for maintenance. So that's that. More stuff, cool. Papa likes his sugar. What? Okay. Right. Okay, so I'll come back to the demos in a bit. What time am I on? Pretty good time. So just a bit about the generated code. I guess it's good to know. So the stuff on the left is Fay. The stuff on the right is JavaScript. So numbers and booleans are the same. Strings are represented as lists of characters, which is the way it's done in Haskell. And things like declaring variables is put in a thunk. Now, in a lazy language, everything is deferred. So they're put inside these closures, which are called thunks. So it's a delayed computation somehow. And then when you need to use it, you force that thunk. So that's the thing, forcing, thunking, forcing, thunking. So a little note about the lists. They're like lists in Lisp. So it's just a linked list of cons 1, of cons 2, of cons 3, and null. It's like that. You can check that out if you're interested. So yeah, this is kind of where the speed hit comes from, and this is the laziness aspect. So on the left is a fake code, and on the right again. Now the function itself is a normal JavaScript function, what it compiles to, right? But it returns, instead of the actual result, it returns a thunk, which when evaluated produces the result. So this is where the speed hit comes in, and this is where you have performance issues, but that's the language. And obviously laziness has advantages, otherwise I wouldn't use it, but we don't need to go into those. Yeah, and data types, again, they compile to a normal JavaScript object, right? This can be optimized by V8 to be a bunch of pointers and stuff like this, right? But again, there are also these wrapper functions, like the second one here, which is curried, which means that every single argument has been, the function of 3 arguments has been changed into a function of 1 argument, which returns another function, which returns another, and so on. I guess you've used currying before, right, in JavaScript, when you're sick of mapping across stuff. Yeah. So that's that. So there are some speed things you can do. So the normal way of doing loops in Haskell is to use recursion. So we don't yet have tail recursive optimization in V8 and stuff yet, but in a lazy language, it doesn't really matter because you get that for free somehow. So the code on the right is kind of what you'd expect. You have the condition here, and then at the bottom you have the tail recursion. But what we can do is replace that with tail recursive optimization. We can detect that it's this particular shape of function and replace it with a loop. So instead of half a second, we come down to 100 milliseconds. Now that's pretty nice, but still it's pretty slow because we have these forces here which are forcing the thunks to evaluate. And you can see inside the loop that all these variables are just, they're not lazy, they're somehow strict. There's no forcing to be done. So you remove that and then you get native JavaScript speed and you're down to 4 milliseconds. So you've gone from this abstract kind of lazy, weird tail recursive stuff to normal JavaScript, but you still have the nice abstraction above. So nailed it somehow. That's good. Or if you don't want to do the strictness stuff, there's a kind of cheap optimizations you can do all the time with JavaScript. Like in this case, instead of having all those forces like this, I can do a check before and sort of inline the forcer somehow. And that brings it down to 50 milliseconds. That's, it's not bad. It's okay. It's cheap. Yeah. Memory-wise, it's not really a big deal that I've been thinking about because all the variables are allocated in the same way as JavaScript. It is JavaScript code, right? So garbage collection happens in the same way. I already tested, allocating huge arrays and then seeing if they are allocated correctly over time and stuff like this. But V8 and JagerMonkey now just they make it difficult to make it use a lot of memory, right? They're really efficient. So if you're interested in that, you can talk to me, but it's not a big deal, I don't think. Onto compression. Now, I think it compresses pretty well. The way I generate the code is really simple. There's only a small subset of JavaScript that I use to generate the code, so there's no weird stuff that compression might break. So I can use Clojure and Uglify.js, and I start off with 68K of Fay code, which produces 91K of JavaScript code, and then at the end, after gzip, I'm down to 4K. So compiling to this is no big deal, right? You can use it on mobile phones and stuff like that. It loads up fine. If you're going to use one of these, Clojure or Uglify.js, I would use Uglify because Clojure takes 4 seconds, and this is only 91K of code, and it takes 4 seconds, whereas Uglify does it in 800 milliseconds. It's not a big deal. So yeah, there's that. So it compresses well. And there are other Haskell-to-JS compilers which are kind of producing a huge code. I don't know what CoffeeScript is like actually compressing. Is it any good? It's like the same somehow, I guess. Yeah. Okay, a final note on the development environment, which is just the same as Haskell. So I use the IDE. I don't have to produce new development stuff. Like for CoffeeScript, you need a whole new editor. You need different analysis tools and stuff like this. Are there actual analysis tools for CoffeeScript, like things in scope, type, stuff like that, completion? Do you get that in CoffeeScript? Anyone know? No? Okay. Yeah, like in here, if I go into the client and I say, I don't know, what do I want to do? Well, any function I get at the bottom, here, the type, and I have completion and stuff like that. It's just part of normal Haskell development. So I have that. I have the interactive REPL, which has inspection and stuff like that. I get to use the Haskell module system as normal, the Cabal package manager, and everything works. So I just use the excellent JavaScript ecosystem with all these really nice libraries, but from Haskell with static typing. Yeah. So future work would be to implement more Haskell stuff, maybe do the strictness analysis, which I showed you, which makes it really fast. And one thing which the talk we saw yesterday, which was updating CSS Live, is really nice. And I would like to do that with Fay. There's already some stuff for JavaScript, like, what was it? In Emacs, you can connect to the browser with JavaScript and then send stuff to it like that. And I want to do that with Fay, so yeah. Because you have the console here at the bottom, but for Fay, I don't have that. So I would like to implement that. I already started implementing source mapping. So here's maybe you can see, yeah. So I compiled some Fay, and I put an intentional error in there, here, which says that the first character in the string should be A, and it's not, so it throws an exception. And what you get in the trace is Haskell stuff, right? The actual line number that you had. So you get a nice backtrace of the actual error. And that's really nice because it feels like a real language in the browser, right? This is showing me Haskell code. It's not showing me transformed JS stuff. So if you're thinking of implementing a language to target JavaScript, there's a lot of good stuff to help you make it feel right and to make it feel more integrated. So that's pretty good. And back to the question at the start, I guess you have the same answer as before. No, if you write unit tests. Maybe not, I don't know. Just a question, have a think about it. For me, of course, I wouldn't have spent so much time if I didn't find that most of my errors could have been caught statically. For example, just a quick, here's a command that I'm handling, and if I delete that and then compile, I get this error, right, which says, I didn't handle that command. And it's the same thing, right? That's not a type check, right? That's a static check of a different kind. And that kind of stuff is nice. And it doesn't have to be a statically typed language. It can just be one that gives you extra assurances, right? So you can like that without liking static types somehow. And that's it. Thanks. Cheers.